important chapter is chemical kinetics. Listen, we go into that as here. Just I want to take it as the chapter of this. 1 minute. Now, 1 minute. So now I want to discuss with some important chapter. The chapters which I want to say as it's a more the easy chapter, as well as in JEE mains they will ask the more number of questions from that chapter alone. We can go with that chemical kinetics. Listen, now in this chapter I want to say as now I can discuss with that chemical kinetics. So in this chemical kinetics deals with what? In chemical kinetics deals with what? We can say that generally the chemical kinetics deals with rate of reaction. Rate means what? The speed of the reaction. We'll go one by one. In this chapter, we'll discuss with rate of reaction. The next, we'll go with that rate constant. Next, we'll go with that what is the order of reaction. Order, and we can say as molecularity of the reaction. And fourth will be is derivation of first order and zero order kinetics. Then fifth will be is nothing but as a Heinous equation. If I complete that, what is over? The chemical kinetics is over. So what is the rate of reaction? The rate means the speed of the reaction, how the reaction is going fast. See, always there is a contradiction between thermodynamics and chemical kinetics. What the thermodynamics deals with? The feasibility of the reaction. Delta G is equal to negative, therefore reaction is spontaneous. But what about in the kinetics deals with? The kinetics always gives information about how fast reaction takes place. We can say there are 1, 2, 3, 4, 5, 7, 5, 6, 7, 8, 9, 10 reactions are feasible. That is called thermodynamics. Among the 10 reaction, which reaction is going faster is called chemical kinetics. Therefore, kinetics as well as thermodynamics both will have they have merits as well as demerits. But here discussing about that chemical kinetics deals with the speed of the reaction, how fast reaction will go. That means if I am writing the generally, if I want to write it as, listen, I am writing as the rate. So what we can say, the rate means the definition of it is, let us take some hypothetical chemical reaction I'm taking. I can write as A plus what is that, B, which gives what we can say C plus what we can say D. It's a normal, I'm taking as a hypothetical reaction. Right? But now, obviously, the rate of reaction depends on the concentration of reacting species as per the law of mass action. So what they are going to say as the rate of reaction, the rate is nothing but change in concentration of reactant, or we can say as product. Here I'll write it, I'll say it different manner by what we can say time taken, or what we can say decrease in concentration of reactant by time taken is equal to what we can say increase in concentration of time taken, increase in concentration of product by time taken. That means I can write it as the rate, that means I write it as R, look at this, minus 1 by A dA by dt is equal to minus 1 by D dB by dt is equal to plus 1 by C dc by dt is equal to, we can write as 1 by d dd by dt. This is what the rate defined as. That means this negative sign indicates that decrease in concentration of reactant with respect to time. At the same time, the increase in concentration plus sign indicates that increase in concentration. So can you give me the example? Look at this. I'm taking the example to understand. Just I draw this one. Listen. Now I can say this is nothing but concentration. This with respect to what time. Now let us take this is reactant. I can say this is one as product. I can say this is nothing but is, I can say as B. This is what A. Look at this. This is the initial time. This is the concentration of is what reactant. Now I can say this is the concentration of is what product. Now look at this. Observe carefully. When the time progresses, obviously concentration of A decreases, at the same time concentration of B increases. That means the rate is nothing but the change in concentration of product by time taken, or we can say the change in the increase in concentration of product by time taken. Here, decrease in concentration, increase in concentration, decrease means minus sign, increase means positive sign. This is what we can say that generally. And now, if I want to go with that as per the rate law, what it says, look at that. Now, if I want to go with the rate law, take the same simple reaction I'm taking as a hypothetical reaction. I can write AA, which gives what B, I can write it. So the rate is directly proportional to, we know that concentration of A power A. Now I want to remove the proportionality constant. I can write R is equal to K into A power A. So what is this? R is called rate of reaction. K is what? Rate constant. K is what? Rate constant. Rate constant of the reaction. What is the small a? Small a deals with the order of reaction. That's all. Now even if I am taking the order of reaction can be 0, the order of reaction can be positive, the order of reaction can be is what? Negative also. It may be anything. Are you able to follow? So order of reaction can be 0, order of reaction can be positive, the order of reaction can be is what? Fractional, order of reaction can be negative. But the order of reaction is what? They will find out experimentally. Order of reaction can be find out is what? They will find out based on the experimental methods. Fine. Now come to the point. Now even I can take the one more simple example to understand. Look at this. I'm taking. Listen. Now let us take one simple example. I'm taking as CH3Br plus what we can say as OH minus, as using as a DMF solvent. DMF means what? Clearly we can say this follows SN2 mechanism. Now I can say that this is nothing but as CH3OH plus what is it called? It's a Br minus. Now what I am trying to say, look at this. Now the rate I want to express that. We can say the rate is directly proportional to concentration of reactant as well as what? Nucleophile as well as substrate. Now K, which is equal to is what? CH3Br. I can write is what here is OH minus. Now what you will think about here? Okay sir, therefore the rate of reaction depends on both the substrate as well as nucleophile. So what is the power here? This is 1. Here also is what? Power 1. Therefore we can say that the order of reaction belongs to the means the overall order of reaction. Overall order of reaction. I can say that the overall order of reaction is what? I can say is 2. Why? CH3Br. Order of reaction with respect to CH3Br is 1. The order of reaction with respect to OH minus is 1. Therefore, the overall order of reaction is what? Second order. That's what this reaction is follows. SN2 reaction. Fine. Alright. How they are going to find out the order of reaction? Please keep it in your mind. If the reaction is elementary reaction, sir, what is the meaning of elementary reaction? See, the elementary reaction means the reaction takes place in single step. The single step reactions are called elementary reaction. In the elementary reaction, you can say that stoichiometric coefficient is order of reaction. Now I can say this reaction is elementary reaction. I can say that stoichiometric coefficient is the order of reaction. Suppose if the reaction is Suppose if the reaction is complex or if the reaction takes place the more than 2 steps. So what you are doing that, what we have to do? That's the reason I told you. The order of reaction they can able to find out experimentally. How is that? Look at this. I want to take one example. So this is the how we can say the rate depends on substrate as well as nucleophile. Now I'm taking one more example that gives a clear cut idea. Look at this. Now I'm taking. We know that I'm taking CH3 as C, CH3, CH3, Br, plus I can take it as a OH minus, which gives is what? Plus Br minus. So what we will think that, okay, here also the rate of reaction depends on substrate as well as nucleophile. Now what they want to find out here, substrate as nucleophile, they are doing experimentally. When they are going to increase the concentration of OH minus ion, the rate of reaction is not changes. Then they are finding out why when I am going to increase the concentration of OH minus ion, why the rate of reaction is not changes. Then they are going to find out going with the mechanism of the reaction. What mechanism? Look at this. When they are going with the mechanism, CH3C, CH3, here is what as CH3. Now is Br. Now here the bond breaking process takes place. Once the bond breaking process means what? It is going to form as what? CH3, as here is CH3, and here also CH, that means it forms a tertiary butyl carbocation. So the tertiary butyl carbocation decides rate of reaction. Therefore, this step is called slow step. The slow step is what? A rate determining step. So in slow step, what species involved? In slow step, the what species is involved, that only we have to consider. So in slow step, what is involved here? Because this is only decide rate of reaction. The slow step is the rate determining step. The second step, look at this. Now I can say that CH3C, CH3, CH3 plus and here is what? The OH minus. Now that this step is what? Fast. When this step is fast, obviously we should no need to consider that. So obviously what I am going to give it as here is what? OH minus. So then they are predicting. That means the kinetics deals with what? The kinetics deals with the mechanism of the chemical reaction. In the mechanism of the chemical reaction, the slow step is what? A rate determining step, which decides what we consider the order of the reaction. The fast step we should not consider. So that means I can write it as here. Look at this. The rate is equal to, I can write rate constant. I am writing as CH3 thrice CBr. Now here is what? Power is 1. Therefore now what I can say here, the order of reaction is 1, even though the 2 species are involved. So here the rate of reaction is not depends on OH minus. The rate of reaction depends on only the alkyl halide. Therefore this belongs to a certain reaction. So how you are going to confirm that? How you are going to confirm that? Let us take one simple example to understand that example, which makes you to clear cut idea. Look at this. Now how they find out? I told you the order of reaction is what? Experimental quantity. Based on the experiment, they will find out it. How? Look at this. Now I want to clean this. From this, you can have the idea. Now they are taking. Look at this. I'm taking. This is the X is. I'm taking as here alkyl halide. This is Y is nothing but is what? Substrate. Now what I'm going to do? Experiment 1. Now I can say this is experiment. I can say 1. I'm making 2. I'm making is what? 3 times. Now I can say concentration of X, I'm giving is what? Concentration of Y, and I'm giving this is what? As the initial rate. Initial rate, keep molar per minute. Therefore concentration is mole per liter. This also mole per liter. So just I'm writing to easy understanding. I'll take it as is what? As just I'm writing 10 power minus 3 to understand this. Now this I am going to double. Right or not? This I am going to double. This I am keeping concentration. Therefore, this becomes what? Now this I am going to keep constant. Alright. And this also, if I double that, so what is happening? Look at this. Now what I did, observe carefully. Now when they are finding out experimentally, when they are doing the chemical reaction, they want to know that the rate of reaction depends on both substrate as well as nucleophile. They are taken the same concentration, it becomes 10 power minus 3 to understand this. Now they keep the concentration of OH minus ion. They increase the concentration of what we can say 0.1 become 0.2. Rate also becomes what? Doubles. Now look at this. The next experiment, they are keeping the concentration of X is constant, but the concentration of Y become double. Still, the rate of reaction become constant. So which clearly says that the rate of reaction, the rate of, that means the rate is not depends on the concentration of Y. How we can find out it by using the based on the rate law expression. Look at this. What rate law says that we know that. Listen. Now I am writing that the rate law says that K into concentration of X power m. I am writing concentration of is what? Y power n and dq. Let us take the experiment. And anyway, please keep it in your mind. The rate constant of the reaction is not depends on the concentration of reacting species. The rate constant depends on only temperature. Look at this. By changing the concentration of the reactant, the rate constant is remain same. That means I can write it. Look at this. I am going to write it as here. I will write it as easy to understand. I will write it as R2 by R1 is equal to K. I can write X power X is what? R2 is what this? I can take it as 0.2 power m, and this will be is what? 0.1 power m by K. Again I can write it as R2 by R1 0.1 power m. This also is what? 0.1. This and this will be cancelled out. Therefore, this K and this K will be cancelled out. Why? The rate constant of the, anyway the concentration only changes, rate constant remains same. What is R2 value? 2 in 10 power minus 3, 10 power minus 3. Therefore, I am going to get this what? 2 is equal to 2 whole power m. Therefore, m is equal to 1. That's all. That means the order of reaction with respect to X is what? 1. First order kinetics. And look at that. In this case, if I am going to take, look at this. These two are constant. When I increase the concentration, rate did not change. Therefore, what I am going to get, if I am going to take R3 by R2, is nothing but 2. Now, anyway, this will be cancelled off. What I am going to get as, which I am going to get it as, sorry, I am going to get it as 0. 1 I am going to get it. Now, here it means what as 2 power n. Now, what I am going to do, 2 power 0 is equal to what? 2 power n. Which clearly says that n is equal to 0, the order of reaction is what? 0 for, that means Y, which means that the OH minus, the concentration of OH minus is not what we can say depend on the rate of reaction. That's all. When I'm going to add the whatever the amount of OH minus, the rate of reaction is not what we can say is going to change, is remain same. This is how they are finding out the order of reaction. So the order of reaction is what? Experimentally computed. The order of reaction they will find out based on the experimental. Now look at this. Now we can go with that the number of reaction. Look at this. Now I am going with that in the exam. They will ask you. Look at this in Heinous reaction. I told you in the organic chemistry. Look at that. They will think that HC double bond OH plus HC double bond OH in presence of the OH minus. In presence of OH minus gives what? CH3OH plus HC double bond O minus and NO plus. So they may think that here the order of reaction of this, anyway we know that aldehyde undergone nucleophilic addition. If the aldehyde undergoes a nucleophilic addition, so what you can say from here? From this we can say that so the order of reaction is 2 for Heinous reaction, because anyway the OH minus only attacking here, like that they may think, but they will find out the based on experimentally the overall order of reaction. This Heinous reaction is what? 3. How? That's what they will give the mechanism. Mechanism says that what? Look at this in mechanism, and I'm going with that. In mechanism, look at this. H C double bond OH plus OH minus. Look at that. Attacking here. This is what we'll think. So nucleophile added. So in Heinous reaction, addition of nucleophile is not what we can slow step. Still, this is what we can say as a fast step only. H C bond O minus. H here is OH. This is called intermediate. Intermediate cannot be expressed in the rate equation. So now I can write it H bond C bond O minus. Here is H and here is one OH. Plus I can write H C double bond OH. Look at that. This step is slow. This step is, that means hydrate transfer is the slow step in the case of cancer reaction. So you will be getting as H C double bond OH plus CH3O minus. Now again that what we can say that proton transfer takes place. This will be faster. Now we can write as H C double bond O minus plus is what CH3OH. Now what we can say? The slow step is what? A rate determining step. Slow step is what? The slow step we can consider as rate determining step. Now what I am going to say that now one thing in rate expression, the intermediate cannot be expressed in the rate equation. So this comes from where? It is coming from the first step. Now look at this. I can write as this is the equilibrium step. Now I can write rate is equal to K into concentration of HCHO and concentration of is what? CH2. I can write as CH3O2 minus to understand this. CH3O2 minus, which is coming from the first step. That means intermediate. Intermediate cannot be expressed in the rate equation. So now this intermediate comes from where? It is come from first step. That means I can write K, which is equal to equilibrium constant K, which is equal to, I can write that CH2O2 minus, and I am writing that HCHO, I am writing is OH minus. Now take that side. So now I can write that in the place of concentration of CH2O2 minus, I can write that K into HCHO and OH minus. Now this value substitute here, I can take it as overall K dash is nothing but HCHO, OH minus. Therefore, we can say that K dash equal to HCHO square and OH minus is rate. Look at that. Now the overall order of reaction is what? Third order for cancer reaction. So that means for complex reaction, so we have to see that which is the slow step. The slow step is the rate determining step. And in the examination, they may give you what we can say particular reaction. In the particular reaction, they will ask you to find out rate expression and order of reaction with respect to is what? What is order of reaction with respect to is what? Finally, they may find out if the concentration changes, what could be the rate constant. So based on that, can we discuss one question? That question which gives what we can say the clear-cut confidence. Now I want to discuss one question. So based on what we can say the order of reaction, can we go? Listen. Now I can discuss one question. Yeah. Now I want to take one simple question which gives the more and more confidence. Listen. Now I am going with that. Let us take. They will ask you to find out. There is a reaction A plus B which gives, I am writing that A plus B which gives what we can say C plus D. They are given like that. And they are giving us experiment. I will go with that experiment. Concentration of A. I am going with that concentration of B. And it is what? Initial rate. Concentration of A and concentration of B and initial rate. They are giving the three experiments. Look at that. I can write it as 1. This is 2.5 into minus 4. This will be 3 into 10 power minus 5. And the initial rate will be 5 in 10 power minus 4. Now that experiment is 2. You can say this will be 5 into 10 power minus 4. And this will be 6 in 10 power minus 5. The rate could be is what? 4 in 10 power minus 3. And the third experiment says that 1 in 10 power minus 3. So it will be 6 into 10 power minus 5, and this will be 1.6 in 10 power minus 2. Now what is the question? Find out the order of reaction with respect to A and with respect to B. Find the order of reaction with respect to A and with respect to B. That's what they are given that, and we will see that what is going to happen. So first what I am going to do, I don't know what is the whether they are given like this. So first I write the simple rate expression. I'm writing rate R is equal to K into, I'm giving what, A power X, and what I'm giving is what, B power Y. This is the generally rate expression. When I'm changing concentration, the rate constant remains same. Now come to the point I'm taking. So anyway, in that B they are keeping same, and here look at this, they are changing 4 times. Look at this, what is happening in the rate of reaction. So now I am writing as R3 by R2. What is R3? 10 power minus 3. This will be what? 5 into 10 power minus 4 is equal to. Obviously, what is going to happen? Anyway, the B concentration cancelled off. I am having only is what as extremely sorry children. I made a mistake here. R3 by R2. R3 is what here as 16 into 10 power minus 3 by 4 into 10 power minus 3. Anyway, this concentration anyway cancelled off. Only we are going to what? R3 by R2. I can write 10 power minus 3 by, I can write 5 into 10 power minus. Now if I cancel off, this will be cancelled. Now I can have is what as, I can write, and this will be cancelled off. 10 by 5. 10 by 5 is what? 2 is equal to 2. Now this is nothing but is what? I can write 2 power x. Now this will be is what as 4. 4 means what? I can write 2 square is equal to 2 power x. Therefore I can say x, which is equal to is what? 2. Now I can say the order of reaction with respect to A is what? Second order. Order of reaction with respect to A is what? Second order. Now come to the point in the case of B, how I am going to find out it. It will be very simple. Take any one of the equation. We can easily substitute and get the value of what? Y. I am taking what is the equation. I'll take it easy to understand. I will take it R2 by R1 and I'm taking is what? R2 by R1. What is R2? I can write 4 into 10 power minus 3 by, I can write 5 into 10 power minus 4 is equal to. Now what I am going to get it? A. A is what? Second order. I am writing as 5 into 10 power minus 4 by 2.5 into 10 power minus 4 as a what? Whole square. And this will be is what? 6 into 10 power minus 5, 3 into 10 power minus 5. I am keeping 4 power is 1. So now this and this will be cancelled off, which I am going to get 2. 2 squared is nothing but is what? 4. Now I want to clean this. Anyway, I have written everything is perfectly. Okay, 6 10 power 3 minus 5. So this will be 5 10 power minus 4, 2.5 10 power minus 4. Therefore 2 squared 4. Now this 4 10 minus 6 10 minus. Okay, fine. So now I can write it as, listen. Here I can write as 2 square, and this will be cancelled off. I can take 2 power y. Now this and this I can write 40. 40 by 5 is nothing but is what? 8. 8 by 4 is 2. Therefore 2 power y. Therefore 2 is nothing but is what? 2 power y. So y, which is equal to is what? 1. Which means that we have discussed y is 1, and I can say what is that x? The x is equal to what? We can say 2. Which means that what is the rate expression you are going to get it? I can write R is equal to K into concentration of is what? A square. I can write what? Concentration of B power 1. So what is the overall order of reaction is what? Third order. So the order of reaction with respect to A is second order. The order of reaction with respect to B is what? First order. Then they will ask you the question, so what could be the rate constant of the reaction? That is what the question. Now I have taken one of the rate equation. I can say that this is the one of the rate I am taking that. Please understand carefully. They'll ask you, find out the rate constant of the reaction. So how to find out rate constant of the reaction? Rate is equal to A squared B power 1. Take any one of the rate equation. I am taking this rate. This is rate. These are all concentration of A. This is concentration of B. Now what I am going to do? Taking as any one of the rate equation, 4 into 10 power minus 3 is equal to K. I can write that A squared is what? I can write 5 into 10 power minus 4 whole square, and B is what? 6 into 10 power minus 5. Just I am taking the example. Just I am taking any one of the experiment. I want to find out what is the rate constant value. Just I am taking. Right or not? Now. So therefore K is nothing but, I can write 4 into 10 power 4 and 10 power 3 by, therefore 5 squared, 25 and 10 power minus 8. This will be 6 into 10 power minus 5. Therefore this and this will be cancelled out. What I am going to have as 10 power minus 3 only. Therefore, this 10 power minus 3, 10 power minus 3 cancelled off. Therefore, we are having 4 into what we can say 25 into 6 is equal to, okay. Still, if I want to simplify this, I can make it as, this is, I can write 100 by 4. And 100 by 400, we can simplify as 2, 3. 1 by 25 into 2 by 3, if I simplify as 12.5. So now I can use that, I can use it as calculator, which makes you some sense actually. Is the calculator, minute children. Now, in this case, if I want to say that as calculator, it will be as 1 divided by 12.5 divided by 3. We can say that 0.026. 0.0266. Very important. The unit is very important. Why is that? Rate is unit 1. You can say as molar per second. What about this will be, it's a third order reaction, don't forget about it. So how to find out the unit of rate constant? Very simple. Now write it as K, which is equal to concentration by concentration power n 1 by T or not is. Now what is the overall order of reaction is third order. When n is equal to 3, we can write it as concentration, that means, okay, concentration by, I can write is what? Concentration as here whole cube into 1 by T cancelled off. Now I have the concentration squared. That means what is the unit of concentration? Mole per liter is the concentration. Now I have the square is there. That means I can write liter square per mole square second inverse. This is the unit. This is what you may expect in the JEE mains point of view. Even they may change the concentration. They will ask you what is the rate of reaction. So that means we can clearly says that the order of reaction is what as experimental quantity. The order of reaction is what? The experimental quantity. So that's all. This is what you have to understand. This is what you have to do that. Alright, so look at this, how they are asking in this one. Now, next one, if I want to go with that, listen. Now I want to clean this. Now, next one, if I want to go. So, derivation of rate constant for what we can say first order and zero order kinetics. Derivation of the rate constant for first order as well as what? Zero order kinetics. Let us go with the first order kinetics. I am going. First order kinetics. in first order kinetics, so what I am going to do, look at this. Let us take on, it's an elementary reaction. Let us consider it gives first order, A gives B. We can write that rate which is equal to A into concentration of A. Now this R I can write minus dA by dt which is equal to K into A. Am I right? Anna? Now if I want to integrate the equation, so minus integration of what is that dA by what is that A is equal to K integration of is what dt. Now what is minus dA by A? We can write as minus ln A is equal to kt plus C. Now I want to find out the C. When we can say that when times equal to 0, we can say that A which is equal to is what? A naught. Now substitute that, we are going to get C which is equal to minus ln A naught. I am substituting in this equation. Now what I am going to get as minus ln A is equal to kt minus ln A naught. Now if I am taking this side, look at this, kt which is equal to, I am writing as 2.303 log of A naught by A. Therefore K which is equal to 2.303 by T log of A naught by A. This is, we can say, the derivation of a rate constant of first order kinetics. What is this A? That means the unreacted A at time t. That's very important. We can say the K is equal to 2.303 log A naught is what? It is an initial concentration. A naught is called what? It is a initial concentration. And what about this A? The A is nothing but the unreacted A at time t. Unreacted A at time t. Don't forget about it. Now, they given K is equal to 2.303 by T log of A naught by A. Is it over? Now, if we want to draw the graph of, look at this. Now, if I go with that as the graph of, look at that, log A versus T. This is what I'm going to get. The slope is what? We can say that minus K by 2.303 is the slope. This is the intercept of what we can say log A naught. This is the graph of first order kinetics. That means we can say all the radioactive reactions are follows first order kinetics. Hydrogenation of ethene follows what we can say as the first order kinetics. So all what we can say the radioactive, natural or artificial, all reactions are follows first order kinetics. Yes. The next is, so what is T half? What is T half? Very simple. T half means, let us take one simple example to understand. So what is T half are? See, there is a substance is there. Let us take the substance A. Alright, this is A gives B, A gives B. Alright. And here I can say the 1 gram. 1 gram of the substance becomes what? That 0.5 gram. Okay, half of its original. For that time taken is called is what? T half. Now this 0.5 becomes what? 0.25. This is another, what is that? T half. This 0.25 becomes what? 0.125. This is called another T half. So now what is that? T half means what? The T half clearly says that, for first order kinetics I'm going to explain it to you. General information about T half is what? When that the 1 gram of the substance become the 0.5 gram, for that time taken is called T half. That means 50% of the reaction is completed. For that time taken is what? T half. Look at the first order kinetics. Now I am going with that K, which is equal to 2.303 by T log of, I am going with A naught by A. Now what is T half? I can say when T is equal to is what? T 1 by 50% completion. Obviously what? A is equal to is what? A naught by 2. Now substitute in this equation, we can write that K which is equal to 2.303 by T half log of A by A naught by 2 cancelled off. Now T half So if I simplify that, log 2 is 0.3010. I am taking as 0.693 by 3. That means T half of the first order kinetics, which is independent of initial concentration of reactant. What is the meaning of this? Very simple. Take the uranium. Uranium 238 become uranium 234. That means uranium. Okay, let us take. So the T half of uranium. Okay, we can say 100 gram of uranium become 50 gram. Time takes 50 years. Even if we take 0.5 gram of uranium, become what we can say 0.25 gram also 50 years only. It's not depends on the amount. Which order reaction? First order kinetics. That means I'm repeating again. Whatever the huge quantity of the first order nuclear reaction, if you're taking uranium, 100 gram become 50 gram is 50 years means even 1 gram become 0.5 gram also 50 years. Even 0.1 gram become 0.05 gram also what 50 years time taken. That is the important of first order. They are not depends on the amount or we can say the concentration of the reacting species. Even I can say what about in this case we can say as look at that. Now if T 75% completed, same thing. What about if you are taking T 75% completed? What is the meaning of T 75% completed? Means what? A which is equal to is what? A by 4. That means I can say 1 becomes what? 0.5 and 0.5 becomes what? 0.25, which means that what? 0.25 is unreactant. That means what we can say that the A becomes A naught by 4, or we can say that 75% of the reaction completed. That means we go for the first order kinetics, we can go K which is equal to 2.303 by T 75% log of A naught by 4 cancel off. Therefore T 75% which is equal to, we can write it as 2 into 2.303 into log 2. Therefore I can write 2 into 0.693 by K. That means I can write it T 75% equal to 2 times of T half. This one what we can say as here first order kinetics. That's all. So this is what related to what we can say answer the question. So we'll discuss the zero order kinetics also. Then we'll go for the Arrhenius reaction. Now come to the point. Now what about the zero order kinetics? Listen, the case of the zero order kinetics, let us take A, which gives what is that product, same thing rate which is equal to K. I can write that A power 0, and the A power 0 means what the order of reaction is 0. Now we can write it dA by dt as minus is equal to K, A power 0 is equal to 1. Now if you integrate that, minus dA integration is equal to K into integration of dt. What is minus dA? The minus dA is nothing but is what? Minus A concentration of A, which is equal to Kp plus C. Now same thing, when T is equal to 0, we can say that A is equal to A naught. Therefore, we can say that C, which is equal to minus A naught when time is equal to 0. Substitute that, you are going to get as Kt, which is equal to A naught minus A. Therefore, we can write that K is equal to A naught minus A by T. Now, if we draw the graph, same logic, A versus T. That's all. So the intercept is nothing but as A naught and time is equal to 0. So this is what we can say now. This is what the logic of the zero. That means all that means gaseous decomposition of ammonia follows first zero order at very high pressure. Right? The decomposition of what we can say the ammonia gas. It follows zero order kinetics. Many of the catalyst reaction follow zero order kinetics at very high pressure because absorption process. And what about in the case of T half of the reaction here? Look at the same logic. Now, A is nothing but is what? A naught by T. I can write that T half is equal to what? Sorry, T becomes what? T half. Now substitute here. I am writing K, which is equal to A naught minus is what? A naught by 2. By is what? T half. Now I can write it as T half is equal to A naught by 2K. Look at that. T half of zero order reaction is depends on T half of the zero order reaction is depends on the initial concentration of reacting species. But first order is what? No. That means we can draw the graph. Look at this. Look at this. Now we can go with that. T half of this is A naught. That's all. This follows first order kinetics. And look at this. When I am going with that T half versus A naught. And say for this zero order kinetics, look at this is first order, zero order or not. Even we can say, please keep it on your mind. Look at this. I'm taking graph versus is what? K. Rate constant versus concentration of A. That's all. That means the rate constant is not depends on the initial concentration of reacting species. That's very important. So these are all the important criteria which we have to keep in your mind. The next very important is Heinous equation. See what Heinous equation talks is it gives information about temperature dependent on rate constant, we can say, or temperature dependent on rate of equation. So what the Arrhenius says that, listen carefully, I want to explain that. He is telling for every 10 degrees Celsius, the rate of reaction is increases by 2 times. For every 10 degrees Celsius, the rate of reaction increases by 2 times. How every 10 degrees Celsius rate of reaction rate of reaction increases by 2 times? He is giving some idea. What is the idea? Look at this. According to his idea, look at this, and he is taking. There are 2 types of reaction. Look at this. I am going with that. This is energy. This is versus reaction coordinate. Look at that. I am taking. That's all. This is I am taking as a R. This is what product. Now I can say this is delta H. Now I can say this is called EAF. Now I can say this is nothing but EAP. That means this is taking the example of exothermic reaction. Look at this difference in the energy of product minus reactant gives delta H of the reaction. Now this is called energy of activation. One definition of energy of activation: the reactant molecule must collide to reach this activated state. Activated state means what? It's an intermediate state. Intermediates are what? They are unstable nature. They immediately decompose, which gives the product. When which gives the product, they may release energy, or sometimes whatever the amount of energy released is not sufficient because they may be the endothermic reaction. In this case, exothermic reaction. How exothermic reaction? You are saying that because products are lower energy level than reactant. That means we can write the delta H of the reaction. You can write it as energy of activation of forward minus energy of activation of backward. For any reaction, we can write it. So delta H is equal to what? Energy of activation of forward minus energy of activation of backward. Now, what the Arrhenius says, that any reactant molecule must collide to reach the activated state. For reaching the activated state, the amount of energy required, the energy is called what we can say activation energy. Alright, this is called an unstable intermediate. When they're unstable intermediate, they what we can say they are very short time to survive. So immediately what decompose? When they are decompose, definitely amount of energy released. When amount of energy released, obviously what here the nature of reaction is exothermic. Come to the point. About in this case I am taking, look at that. I can take it as now. Now I am taking in this reaction same energy this is reactant product. Now I can say this is delta H of the reaction, delta H, and this is nothing but as energy of activation of forward. This I can say as energy of activation of backward reaction. And look at the same thing, reactant molecule must collide to reach this state in their unstable state. So when they are going to, what we can say, decompose, which gives product. But in this case, whenever decompose, amount of energy released. But due to the endothermic in nature, the amount of absorbed energy is higher than the amount of energy released by what we can say the intermediate. Therefore, here the nature of reaction is what? Endothermic reaction. This is endo. This is what? Exothermic. Now, what I am trying to say in this case, please keep it in your mind. For energy of activation is less, reaction is going faster. Why? Look at this. In this case, I can say the energy of activation is less, therefore they reach immediately, they use power. But in this case, the energy of activation is more. This will be energy of activation of forward. Look at this. In endothermic reaction, energy of activation of forward is very high. For exothermic reaction, energy of activation of forward is less. Therefore, here the reaction going faster. That's the reason generally they will say exothermic reactions are generally faster than endothermic reaction, because endothermic means you have to supply the energy to break the bonds. Are able to follow what I am trying to say? So, what Arrhenius says that for any reaction, this is the general idea. But what Arrhenius is saying that, look at this, he has taken the fraction of molecule which we have discussed already in the gaseous state. Look at that. Now, I can say as, look at, I am going with that as, I am going fraction of molecule versus kinetic energy. That means what Arrhenius says that anything which crosses the energy barrier, they may take part in the chemical reaction. Look at this. How I am writing. This is the what we can say. I can take the temperature of what? T1. Now I can say the fraction of molecule having very high kinetic energy, only those molecule only going to take part in the chemical reaction. Why? Those molecule only, as I told you the graph. This is the graph I told you that, isn't it? So these only, those molecules only cross the energy barrier, they are going to take part in the chemical reaction. Am I right or not, sir? No. That means here there are 100 molecules are there. In the out of 100 molecules, only the 20 molecules are having energy greater than the activation energy which take part in the chemical reaction. Energy greater than or equal to energy of activation. Right or not, Cesar? So now the point is when increased temperature, look at this, when increased temperature, that's all. Now look at this, I can say this will be what? T1 plus 10 degrees Celsius. Here T1 degrees Celsius, I increase 10 degrees Celsius. Look at this, the area become what we can say, it's become broadened out. And I can say that if you observe, look at this, like this, I make it like this. And look at this. Okay. Now please understand, when I increase 10 degrees Celsius, that means T1 and T1 plus 10 degrees Celsius, what is happening? The more molecule crossing the energy barrier, which means that what? Suppose here 20 molecules are there when temperature is T1 degrees Celsius. When I'm making T1 plus 10 degrees Celsius, the number of molecule having the fraction of molecule having energy greater than equal to energy of activation. That means the more molecules are going to take part in the chemical reaction. When more molecules take part in the chemical reaction, obviously I'm going to get the product, therefore the rate of reaction increases. Now observe that This is when temperature is what T1 degree Celsius. This is what we can say as T1 plus 10 degrees Celsius, almost double or not. That means can we say that every 10 degrees Celsius the rate of reaction is what increases 2 times. That's what Arrhenius says. Are able to follow? That means in a chemical reaction, all molecule is not going to take part of the chemical reaction. Only the fraction of molecule having energy greater than or equal to activation energy, they are going to take part in the chemical reaction. When temperature is T1 degrees Celsius, only I can say the 20 molecules out of 100 molecules, 20 molecules take part in the chemical reaction. When increased temperature, I can say 40 molecules or 50 molecules energy having greater than energy of activation going to take part in the chemical reaction. The rate of reaction increase by 2 times. Now look at the area under the curve also. This is 1 means, I can say this is 2 means, I can say 4 times. It almost double when temperature increases. That's what Arrhenius says. Then Arrhenius says that is giving the equation K, which is equal to A e power minus EA by RT. Energy of activity, that means this is called, we can say that E power minus EA by RT, the fraction of molecule having the energy of activation. This is what he's trying to say, this E power minus EA by RT, the fraction of molecule having what we can say kinetic energy greater than or equal to what? The energy of activation. That's what this term is trying to say, that E power minus EA by RT. And what is that? Look at this. This is what he's telling. Now K is equal to A e power minus EA by RT. Now take the log both the sides. Log A minus EA by RT into 2.30. Now if you draw the graph, that means if you draw the graph, if I draw the graph, what is the graph? Look at this. Log K versus 1 by T. Now what I am going to get as intercept is log A, slope is nothing but minus EA by R 2.303. If I am taking two different temperature, so what is that going to get it? Look at this, log of K2 by K1 is equal to EA by R into 2.303. You can say 1 by T1 minus 1 by is what? So now we can have, this is what the Heinous equation says that. The interesting point which I want to say here, addition of catalyst, very important. When you are going to add the addition of catalyst, the rate of reaction is faster, right? Catalyst does not initiate the reaction because reaction been already initiated, but reaction is slow. Catalyst does not, what we can say, initiate. Catalyst speed up the reaction. Why? Because it provides alternate path for the chemical reaction. Look at this, I want to say here. Now, when I'm going to addition of catalyst to the chemical reaction, so what is going to happen? Look at this. Now, addition of catalyst. Now let us take, I'm taking one example. Look at this. Now I'm taking same way. This is energy versus reaction coordinate. Now look at this, I'm going to take one reaction. You can say this is reactant, this is product. Delta H. Now I can say this is energy of activation. Now this is what I can say as, this is without catalyst. Now I am going to add the catalyst to the reaction, and I am going to add the catalyst. Look at this. So this what we can say with catalyst. So when with catalyst, what do you observe that? Look at this. Energy of activation decreases. But what about delta H of the reaction? Delta H of reaction, the heat of reaction remains constant, is not depends on addition of catalyst. Why? When I'm going to add catalyst, energy of activation of forward, at the same time energy of activation of backward decreases to the same extent. So that means I can say that addition of catalyst delta H remains same, because delta H is what? EAF minus is what? EAB. That means energy of activation of forward decreases and energy of activation of backward decreases to the same extent. Delta H remains constant, but the rate constant changes. Rate constant change. When the rate constant change, and what about equilibrium constant? The equilibrium constant remains same. Why? I can keep it K, which is equal to Kf by Kb. What is rate constant of forward? Rate constant of backward defined as what? Equilibrium constant, which means that when I'm going to add the catalyst, the rate constant of forward and the rate constant of backward increases to the same extent. Therefore, the equilibrium constant of the reaction remains same. When equilibrium constant remains same, we can say that delta here also will not change. That means what we can say, the addition of positive catalyst, we can say that equilibrium constant, delta G naught and delta H of the reaction remains constant, but the rate constant, and we can say the energy of activation only is going to change. So from this, we can write it as, look at this, now I can write it as, for assume that for this reaction pre-exponential factor is same. Now I am taking as Kc by K1. What is Kc? Kc means addition of catalyst. K1 means without catalyst. So A e power minus EAC by RT. By I am writing is what? EA1 by RT. K minus will be there. Now when I am going to add, what is going to happen? The energy of activity decreases. Now I can make it as difference is what? E power delta E by RT. Therefore, Kc is equal to K1 e power delta E by this is what you may expect in this type of questions. Can we discuss one question, one simple question I want to tell you? For particular chemical reaction, the rate of reaction increases triples. Rate of reaction increases triple when temperature increases 30 degrees Celsius to 40 degrees Celsius. I can say the rate of reaction triples when temperature increases from 30 degrees Celsius to 40 degrees Celsius. Calculate EA in kilocalories. That's what they're asking. Now look at this. Now rate of reaction triple. That means I can go with the Heinous equation. We can write that K2 by K1 log of. I can write that EA by R 2.303. We can write that as P2 minus P1. By we can write is what? P1 and P2. Now log K2 by K1 is what? Rate of reaction triple. That means I can write log 3 is equal to EA. I am asking in terms of kilocalorie, therefore R value 2 into 2.303. Now mention as 30 degree means I can say this is 10. 30 means what? As 303. Now we'll use, I will discuss that. Now log 3 value, let us go with that. Log 3 into 2 into 2.303 into 303 into 313 divided by 10. We're getting the answer as what? As 20.842 kilocalories per mole. This is what these type of questions. It's a very simple question I have given that. They will ask you to find out. So can we go for one more question? Ready? Now look at that and take the one more nice question that gives them more and more confidence on you. Look at that. Yes. Mm-hmm. I'm taking one simple question. That simple question which makes you to better understanding. Now, they are given the rate of decomposition of first order. Look at this. Now I am taking as log K. Look at this, log K is in per second. They are given is what? 14.34 minus 1.25 into 10 power 4 by T. This will be what in Kelvin. Now they are finding out EA of the reaction. So this follows first order kinetics. They will ask you to find out. Look at this. So how to find out E of the reaction? Compare. What comparison you do? Log K is equal to log A minus EA by RT into 2.303. Compare this and this. Therefore, 1.25 into 10 power 4 by T is equal to EA by, I'm asking what we can say EA. We can express EA in terms of kilocalories. Therefore, 2 into T into 2.303. This T will be cancelled off. Therefore, 1.25 into 2 into is what? 10 power 4 is equal to EA. Therefore, 1.25 into 2 is what? 2.5 into is what? 10 power 4 calories per mole. Therefore, I can write as 250. Can write 2.5, 25. 25 kilocalories per mole is equal to. Oh, look at this. What type of questions? Can you go one more question? One more question which makes you more and more confident. Listen. Come to the point. Listen. One more question. I'll discuss the question. Yeah. They given that as the X-use product. You can say that X-use product. It follows first order kinetics. Follows first order kinetics in 40 minutes. In 40 minutes, the concentration of X changes. Concentration of X changes from 0.1 to 0.025 molar. Now find the rate of reaction. Find the rate of reaction. Find the rate of reaction when concentration of excess is 0.01 molar. So the question is X-use product. In 40 minutes, it follows first. In 40 minutes, the concentration of X changes from 0.1 molar to 0.025 molar. Find the rate of reaction when the concentration of X is 0.01. So anyway, this idea is follows first order kinetics. Now we can use first order rate equation. I can say that K is equal to what? 2.303 by T log of A naught by A. What is initial concentration is what? 0.1. And this will be is what? 0.025. Able to follow what I am trying to say? Now I can write it as 2.303 by, I'll go with the 40 log of zero point 0.1 by 0.025 is K. Now this I can say as a log 4. What is a log 4 value? We can say log 4 means we can take it as a 0.6010. That means we can take it as 2.303 into 0.6020 by 40, which is equal to K. Now what is that asking the question? What is the rate of reaction? If the concentration of X is what? 0.01 molar, take the rate is equal to K. Concentration is what? 0.01. Now K value is what? You can say that 2.303 into 0.6020 into 10 power minus 2 by 40. If I am simplifying, if I get the answer, I can take it as 2.303 into 0.6020 divided by 40. We are getting the answer of 0.034 into 10 power minus 2. Unit is, this is what rate is nothing but as molar per minute. This is what the real JEE mains question. This is what you may expect in the JEE mains. Are you able to follow, children? Can we go one more question that gives the one more question which gives the more and more confident? Look at that. Now I want to go with that pressure question based on the pressure in exam how they will ask you. I will discuss the question that gives the more and more confidence. Look at that. Now I am taking, look at that one simple question, pressure based question. What is a pressure based question? They are given the gas phase decomposition of dimethyl ether. Dimethyl ether is nothing but as CH3O CH3, which gives us CH4 H2 and CO. CH4 gas, H2 gas and CO gas, which is given. They are given as it's a constant volume at constant temperature. They gave us T half of the reaction is 14.5 minutes. T half is what? 14.5 minutes. And they mentioned as the initial pressure of the system is initial pressure. .4 atmosphere. Anyway, volume and temperature is constant. Initial pressure was 0.4 atmosphere. And what will be the total pressure after 12 minutes? What will be the total pressure after 12 minutes, assuming ideal gas behavior? So this is what the question is given. So how to approach the here? Temperature is constant and what volume is constant. Let us assume that 500 degrees Celsius. So how to approach the question? Very simple. Write the reaction. Anyway, they said this follows first order kinetics. All are gas phase. First I am writing. Look at this. CH3O CH3 gives us CH4 gas plus H2 gas plus CO gas is given. Now when time is equal to 0, and times equal to 0 is what? What is the only CH3 dimethyl ether is present? What is the pressure is given? 0.4 atmosphere. When times equal to 12 minutes, or we can say this is 0.4 minus x. This will be 0, 0, 0. I can take this is x, x, and x. What is the atmosphere? What is total pressure of the system? We can say that means PT, which is equal to overall. We can say as 0.4 minus x plus x plus x plus x cancelled off. I can say that 0.4 plus 2x is PT. Okay. Now I want to find out is what x1. If I come to know that, I can able to find out what is the total pressure. This follows first kinetics. Now I can write as K is equal to is what 2.303 by T log of, I can write that A naught by A. I told you anyway temperature and volume is constant. As per the ideal gas equation, we can write that PV which is equal to nRT. Right now I can write that P which is equal to CRT. N by V is the concentration. Therefore temperature anyway is constant. Therefore pressure directly proportional to concentration are matches. That means I can take it K which is equal to is what 2.303 by T log of, I can take it what P naught by, here I am taking PA. PA is what as this. Now the question is how I am going to find out as K. They gave the T half. T half is what 14.5 minutes. That means I can write it K is equal to 0.693 by T half is what 14.5 is equal to 2.303 by 12 log of initial pressure is 0.4 at 12 minutes. What is that? PA will be 0.4 minus x. Now if I am finding out the x value, I will using calculator, I will simplify and tell you. That means 0.693 into 12 divided by 14.5 divided by 2.303. You may get it as 0.4 by 0.4 minus x equal to 1.774. Now if I will be getting as 0.4 is equal to 0.0709 minus 2.774x. Look at this, minus 0.4 divided by 1.774. We are getting as x, you are going to get as, I'll write it here, x which is equal to 0.174. I am substituting here, x I got it, substitute here 0.4 plus 2 into 0.174 into 2 plus 0.4, I can say 0.749. So the total pressure is what? PT is equal to 0.749. This is how many calculations involved. So these type of questions, the calculation part, they may ask you. Look at this, the question, how I have given that. Are you able to follow this? These type of questions are one more. The interesting question I'll discuss now, which makes you the more and more confident. Look at this. Another one question I'll give you, which gives the clear-cut idea. Look at that. I want to give you that question. Now, I want to clean this. Listen. Listen. The last question. Then after we move towards the chapter is called the solid state. Now, very simple question. I'm going with that. Listen. They gave consider the following the reversible reaction. Consider the following reversible reaction. They said consider the reversible reaction. I can say that A plus B gives C plus D. They given, and they are telling that the activation energy of backward reaction A B exceeds that of energy of activation of forward by 2 RT in joule per mole. They given. And this reaction, energy of backward reaction exceeds that of the energy of activation of forward reaction by what we can say as 2 RT. So what is given? It exceeds. Able to follow? Now, next what they are given is 2 RT in joule per mole, and the energy of, that means pre-exponential factor AF, pre-exponential factor forward is 4 times that of pre-exponential backward direction, and find, or we can say delta G naught of energy at find the delta G naught at 300 Kelvin. Find the delta G naught at 300 Kelvin. So how we have to find out the delta G naught at 300 Kelvin? Question mark. How to find out it? Slowly you may start. Listen. Now I'll take that. First, I want delta G naught. Write the equation one by one. We'll go with that. Delta G naught is equal to minus RT ln K. Now what is K? K is nothing but I can write as KF by KB. What is KF? I can write that AF. I can write minus EAF by RT. I can write that minus, again here will be is what, AB T power EAB by RT. Therefore AF by AB, what, how much time? 4 times. Now I can write that 4 T power, I can write that EAB minus what we can say EAF by RT. Now they said how much time? It's a 2 RT. 4 into T, 2 RT by RT. Cancel. Now I can substitute that delta G naught is equal to minus RT. Ln K is what? 4 into T square. R value is what? R is 2. Temperature is what we can say as air. T is 300 Kelvin. If we simplify that, delta G naught is equal to minus calories. This is what the real, what we can say that the JEE mains they are asking that. But down. Is it clear? Please write it down. I'm giving this question for 2 minutes. Please copy that. This give you what we can say that the lots of idea you may get it. Please understand and logically you think. Yeah. So can we go for next one? 1 minute. this is now better clarity. Now next one, I want to give you that Yeah, so that is what I told you. This is what the question. Please understand. So now the question is what the reversible reaction A plus B gives C plus D. Energy of activation of backward exceed that of energy of activation of forward by 2 RT, and energy that means pre-exponential factor of forward is 4 times that of the pre-exponential factor of backward. Find delta G naught at 300 Kelvin. That is a question. Now we can write delta G naught is equal to, we can write it as minus RT minus RT long K. K is what? Equilibrium constant. Kf by Kb. What is Kf? Rate constant of forward. We can write AF e power minus EAF by RT. AB means what? Pre-exponential factor for backward direction. Right or not, sir? Now we can write it again. If you simplify, you may get the answer of delta G naught minus 8,500 calories. So this is what the JEE mains type of questions may expect. Now the come to the point is the one more interesting question which I want to give you. Then we'll move towards the solid state. So now I'm taking as the last question of kinetics that gives the more and more idea. That will be making more interesting question. I'll tell you. 44 page number. Yeah. Yeah. They're telling that hydrogenation process. Hydrogenation process. Hydrogenation process. They are doing at 500 Kelvin. Hydrogenation process they are doing at 500 Kelvin with the same reaction. If same reaction they are doing, means carried out presence of catalyst at 400 Kelvin at same rate. At same rate, they're asking calculate the energy of activation calculate EA. If catalyst lowers EA by 20 kilojoule per mole, is the question. So very nice question this is. Look at the question, I am repeating that. There is a hydrogenation process. They are carried out at two different temperature with the same rate. One is absence of catalyst, another one is presence of catalyst. Temperature is what? 400 Kelvin. This is presence of catalyst, this is what? The absence of catalyst. And what they are asking, find out the energy of activation of absence of catalyst. Now what I am going to look at this. Now anyway, this is the line is important. Rate is same. The rate is same means what? I can write as R1 is equal to R2. Rate of reactions are same. Therefore, I can write that A e power minus is what? EA by RT. I am giving is what? A e power minus EA by RT for the same reaction. Cancel off. Now I am going to keep the energy of activation for what we can say uncatalyzed reaction. I am giving X e power minus X by R into is what? 500. Here it will be is what? E power, I will keep it as X minus 20. Yeah, I can give it as minus X minus 20 by RT. R cancelled off. Therefore, I am going to get as X by 500. Nothing but X by minus 20 by 400. Now what I am going to get as 400x is equal to 500x minus, I will take it as, now I can take it as 100x is equal to x is nothing but that means the energy of activation of the presence of catalyst is what? As 100 kilojoule. Extremely sorry. Absence of catalyst 100 kilojoule. Presence of catalyst will be is what? 80 kilojoule. Now we'll go more towards the solid state. It's a very important chapter. In solid state, generally what we'll discuss in that. Now the last topic of, I'll go with that. Solid state. We'll go with that what is unit cell. Go with that very simple unit cell. Then we'll go with that primitive cell. After primitive cell, we can go with that BCC. We'll go with that CC. And relation between D and A and what is that? R. Radius A and what we can say distance between the two nearest neighbors. Then after that we can go the density calculation. So what is the formula of the density calculation? And mainly we are focusing is what? Primitive cell and body centered cubic, and what is that? The face centered cubic. And what is the unit cell? And finally we can go with the Frenkel and Schottky effect. And metal excess defect. I mean non-Stockian defects. If I complete that, the solid state will be over. And what is tetrahedral voids and what is the octahedral voids? Right or not? Now we'll go with that the one by one, which I want to go with that. What is unit cell? Generally, if I am focusing about that unit cell, is it? That's all. This is smallest portion. That's all. This is called a unit cell. So this is smallest portion, which is present in the what is a unit, which is keep on repeating, which gives the the three-dimensional, what we can say, the cubic solid, we can say, smallest portion, right? So the unit cell depends on 6 parameters. This is edge length, I can say this is A, I can say B, I can say C. The edge length is have, or we can say angle. We can keep alpha, beta, and gamma. So based on this, we can decide that when what we can say A is equal to B is equal to C, we can say alpha is equal to beta is equal to gamma is equal to what, 90 degree. We can say it's called cubic. That's what discussing that. From the unit cell, from the what we can say edge length, from the what we can say angle, if A is equal to B is equal to 0, alpha is equal to beta is equal to gamma is 90, they belongs to is what? Cubic unit cell. In the cubic unit cell, we have that what we can say 3 important derivatives. That is, what is that? We can go with the primitive cell. I can go with the body center. I can go with the phase center. Look at this. I am going with the in cubic. I am going with that as PC. PC means what? Primitive. Same thing. I am going with that BCC. I'll explain you. Now I am going with that. Now I can say this is FC. That means what is that? Primitive cell. Primitive cell means the atoms or ions or molecules going to occupy only corners. One. They are going to occupy the corners. So the atoms, each corners are going to share by 1/8 of the unit cell. Now we can say that there are 8 corners. The corners going to share by 1/8. Therefore, the number of atoms present per unit cell is what? Unit cell. Now, in the case of BCC, they belongs to non-primitive. This is primitive. What is non-primitive? BCC and FCC. What does the BCC means? The atoms not only occupying what we can say the corners. They are going to occupy body center. An atom in the body, which means that there are 8 corners. Each corners of the unit cell shared by what we can say 1/8 of the atoms. Therefore, we have 8 corners. 8 into 1/8 plus 1 which is in the body center. So the total number of atoms per unit cell in the BCC is what? What about FCC? Phase center cubic, which means that what? The atoms not only occupying corners, they are going to occupy each phase. 1, 2, 3, 4, 5, 6. Now we can say that each phase is shared by what we can say the half of the unit cell. That means there are 6 phases are there. Each phase is going to share what we can say 1/2. Now I can write it as there are 8 corners. There are 8 into 1/8. 6 phases. Each phase shared by half of the unit cell. Therefore, I can say 1 plus 3 is equal to 4 atoms per unit cell. That's all. Now this one, we can made in relation. This is only talking about atoms. That means crystalline solid, atoms crystallizes, molecule crystallizes. I'm not going with ionic solids. Ionic solids is different. Now in this case, I'm going with that easy relation is what. Now I can say anyway. That means, which means that what? Always there will be what we can say the corners. They will be touch each other like this. All spheres are, because atoms are spherical shape, so they touch each other. Now I can say this is A. Now this, if I am going to keep it like this, I can say is what 2R. Are able to follow? That means I can say that in this case, A, which is equal to is what? 2R. R is equal to what we can say? A by 2. From this, we can able to find out the efficiency of the, what we can say, the primitive cell. Efficiency means what? Volume occupied by atoms by total volume is called, you can call this a packing efficiency. Now we can say volume. So volume, how many atoms are occupying here? You can say 4 by 3 pi r cube. I can write it. One atom is occupied as in a primitive cell. I can write 4 by 3 pi r cube by, or we can say as volume is what I can be able to say a cube. That's all. Now r cube is what we can say that, right? R is what? A by 2. That's all. 4 by into a cube by 2 cube by, or we can say a cube. Cancelled off into 100. This is what we can say the packing efficiency of, or we can say primitive cell. And what about in the case of body center cubic? Very simple. Take it same way. I can go with that body center cubic. Now I can say, listen, I'll take it as a body center cubic. The nearest neighbors, observe carefully. That's all. So this is the atoms are there. Now I can go, this is the body diagonal. The atoms are there. Now let us make it. Here also what atoms are going to occupy, here also is going to occupy, and here also is going to occupy. Now I can take it very simple. Let us make it. If I simplify very simple, I'll go directly formula. I can go with that. R, which is equal to root 3 by 4 into A. This is for what we can say as BCC. We can prove that by using that Pythagoras theorem, but I am going directly. R is equal to root 3 by 4 into A for BCC, for atoms are occupied. Atoms are molecule, not for crystalline solids, not ionic solids, crystalline solids. What about in the case of FCC? You can say R, which is equal to, if I want to simplify that, and I go with that as they are going to occupy as, that's all. This only we have to see that. As here the spheres are there. Now let us make it A, B, C. I can write that AC square nothing but 2A square. AC is equal to root 2A. And what about as this is? I'll go with that as A square AC. This is AC is nothing but 4R is equal to root 2 by A. Now, what is R? R is nothing but A. This is for FCC. Now we can go with the packing efficiency. What is packing efficiency? Number of atom here is what? 2. 2 into, you can, this is R 4 by 3 pi R cube. So root 3 by 4 A cube by what we can say A cube. Are able to follow? Same here also. Number of atom is what? 4. Are able to follow? So from this, So this is only for metal crystallizers. For solid crystallizers, from solid crystallizers, if we go the density, I can go D, which is equal to, and write Z into M by, I can go with that Na into AQ. That's all. This is what the logic. That's what the logic of this. Now, if we know the Z is what number of atoms, M is what we can say as a molecular atomic weight of crystalline solid, and Na is what Avogadro number, A cube is what edge length. Over. But in the case of ionic solids, let us take the ionic solids. What they talk about tetrahedral and octahedral voids. Let us go with that. In the case of NaCl, because there's number of the means NaCl. NaCl, I am going to one is what? Cesium chloride I am going. If time permits, I'll discuss with ZNS. What is here? They will say that Na plus and what is that Cl minus as per the radius ratio rule. R plus by what we can say that R minus, which means that the radius of cation, radius of cation, radius of anion ratio, they form belongs to what we can say 0.4142, 0.732, which means that the Na plus is going to occupy in octahedral voids. So we can say that in a cubic unit cell, the number of atom is equal to what we can say number of octahedral voids. Therefore, we can say that Na plus occupy octahedral voids and Cl minus follows CCP pattern. CCP pattern means what? They occupies corner as well as what we can say face. That means here number of Na plus is what I can say 4 Na plus. Here is what I can say as 4 Cl minus. So the total number of NaCl units present in the per unit cell is what? 4. Now therefore I can say that 4 Na plus, I can say that what 4 Cl minus, therefore I am having is what 4 NaCl units present in the per unit cell. That means look at this, I can say like this is there, and what is going to occupy here is Cl minus, here is what Cl minus, here I can say is Na plus, because generally octahedral voids present in the center the same 1, 2, 3, 4 edges. Like that, how many edges are there? 12 edges. That means I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges are there. Am I right or not, sir? No. So 12 edges. That means this is going to share by 1 by 4. So 12 into what is that? 1 by 4. This is the going to share. So therefore we can say is what? 3 octahedral voids per unit cell apart from one center. Therefore 3 plus 1 is equal to 4 octahedral voids. In a cubic unit cell, if it is n octahedral voids, means we can say 2n tetrahedral voids. So please keep it in your mind. So now why I am giving this? Now I can say this is R minus, this is what 2R plus, this is what we can say R minus. Therefore I can write that as for ionic solids of CCM NaCl, don't forget rock salt. I can write 2R minus plus 2R plus is equal to A. Therefore, R plus R minus is equal to A by 2. Don't forget about even I can say, therefore, this is coordination number is what? 6 is to 6. Because 6 Na plus ion surrounded by what we can say? Cl minus ion, and 6 Cl minus ion surrounded by what we can say? Na plus ion. Therefore, the coordination number of NaCl is what? 6 to 6 is to 6. Even I can say Cesium chloride. Coordination number is what? 8 is to 8. Therefore, we can write R plus R minus is equal to root 3 by 2 into A. For please keep it in your mind. This follows FCC. This follows PC. It's an ionic crystal. This what we can say that what I given the previous one, it is only for what we can say atom crystallizers, molecule crystallizers. Here what we can say ionic crystal. Ionic crystal means R plus R minus A by 2. Here R plus R minus equal to root 3 by 8. Root 3 by 2 into A. Now we'll go for the question. The questions which gives you what we can say confident. Now come to the point. Now I want to clean this. We'll discuss one or two questions about solid state that gives the easiest idea. Now, yeah, they're giving us the question. I can say as listen, a very simple question I want to give you. The element crystallizes element. Understand? I'm writing the question. The element crystallizes. The element crystallizes in BCC. The element, not ionic form. Element crystallizes in BCC. BCC lattice. The edge length A is equal to 0.351 nanometer. And density is what? 0.533 gram per centimeter cube. Find the atomic weight. I'm taking very simple question. So now A, first write it. A which is equal to 0.351 in 10 power minus 9 meter. How to convert? Please keep it in mind. Meter to centimeter or centimeter to meter. Meter to centimeter to meter means 10 power minus 2. This will be what we can into 100. That means we can say that 0.351 into 10 power minus 7 centimeter. Then only the unit must be what we can say. Are you able to follow what I am trying to say? Now what is that? BCC. We can go with that B, which is equal to what is that? BCC. It follows 2. I want to keep it as X by Na is what? 6.02 10 power 23 into AQ. Point. I'll go with that as 351 10 power minus 10 as 4 kilo. Now if I am simplifying the value of X, density what is given here? Density is nothing but as, okay, very simple. I will do that using by calculator easy. 6.02 X 123 into 351 into, that's all, into I can say as 0.533 divided by 2, I get as 6 point. That means approximately 7 is the answer. Lithium is the answer. So, it's a very, very simple questions which I given to you. Can you go one more question? One more question which makes you to more and more confident. Look at that. The next question, I can go with that as they given the radius of Cl minus is 181 picometer. Going with that. The radius of, look at that, the radius of Cl minus is Cl minus is 181 picometer, and radius of Na plus is 51 picometer. Find edge length. See, using edge length, they may ask you to find density also. First, I'll go edge length. Look at this. NaCl units. Just now I told you. R plus R minus is equal to E by 2. Now we can write 181 plus 51 into 2 is equal to 8. Now 181, 51, 2 should be 3. This is 132. You can say that 132 into 2, which is equal to 8. You can write is what? 264 picometer. Right? They may ask you that the density of the NaCl also providing this. So how to? So this is how you find out the A value. Now, are you getting my point? From this, now if I want to ask you to find out as what we can say, ask you to find out just I given 181. It's a rough value only. Now I am asking you to find out density of the solid of NaCl. Assume that 181. It's a not exact value, just approximate only because to calculation what I given that. Now, find out the density of solid. See, now we know that D is equal to Z into M by A cube into Na. Now, D you express in terms of gram per centimeter. Now, this is picometer. 264 into 10 power minus 10 centimeter. Z is what? 4. NaCl is what? Molecular mass 35.5, 58.5 by A cube is what? 264 cube 10 power minus 13 into 6 10 power 23 is equal to D. That's all. So now look at this. The logic of the question is what? They ask you to find the edge length, but what I am giving the information, sometimes they may ask you to find out density. They never provide the edge length. So edge length you want to find out. From the edge length you want to find density of the what we can say NaCl crystal. This is what they may ask you about that. We know that Schottky defect and Frenkel defect. See, Schottky defect, density of solid decreases. Frenkel defect, no. Please keep it in mind because of they are, what we can say, as the case of Schottky defect, equal number of cation anion missing from the active site. Therefore, to what we can say, maintain the masses overall properly. So density of solid is what? Decreases. But in the case of Frenkel defect, this what is going to the electron is going, that means the A plus is going to occupy in interstitial sites, which create a hole. That's called Frenkel defect. That's all. Metal excess defect, for example, sodium lamp, we were heating that by using the C, which produce color F centers. Why? Because when I'm going to take it as a Na, we are going to, what we can say, that NaCl, what is going to happen? Na becomes Na plus, electron is there. The electron is going to occupy what we can say in the NaCl, in the place of Na plus, the lat is going to occupy there. Are you able to follow what I am trying to say? So because of that, electron is called F center. The F center responsible for what we can say produce color. This is about the solid state. One more thing, zinc blend in Zn2 plus. Keep in your mind, generally what are JEE means, just zinc blend ZnS. Zn2 plus An occupies in tetrahedral voids. How? It occupies in alternate tetrahedral voids. If we have in a cubic unit cell, if we have that n number of octahedral void, means we have the 2n number of tetrahedral voids. That means we can say in the 8 tetrahedral voids in per what we can say unit cell, in the 4 octahedral voids being the what we can say cubic unit cell. So we are using the CCP term. CCP means what? Cubic close packing, which means that anything they mention CCP pattern, they occupies corner as well as each face. Number of atoms is 4. That is the logic of this, children. That's all. So physical chemistry is over. Organic chemistry is over. Now we have an inorganic chemistry. So the request to everyone is what those who are listening my classes. So practice the problem. Practice the problem which makes you to more and more confident. So last what we can say 3-4 years of paper you take it. So organic is over. Physical chemistry is over. So that means 70% of the chemistry portion is over. So the practice the what we can say the 70% which you have learned now, and practice and gain the more and more confidence. So you have the April. Last week you had an exam. So prepare and do well and line by at least you can answer minimum 15 to 16 question if you attend only physical and organic itself. So I am more confident on you. You do well. I'm very happy to see that you are listening the class carefully and you are attending effectively. So I hope you'll do very well in JEE mains. So thank you so much, children. All the best. We'll meet next class next week. Thank you.